Population growth is currently under-discussed. This may be partly because doom-laden forecasts of mass starvation in, for instance, Paul Ehrlich's 1968 book The Population Bomb and the pronouncements of the Club of Rome have proved off the mark. Also, some deem population growth to be a taboo subject, tainted by association with eugenics in the 1920s and 30s, with Indian policies under Indira Gandhi, and more recently with China's hardline one-child policy. As it turns out, food production and resource extraction have kept pace with rising population. Famines still occur, but they're due to conflict or maldistribution, not overall scarcity. We can't specify an optimum population for the world because we can't confidently conceive what people's lifestyles, diet, travel patterns and energy needs will be beyond 2050. The world couldn't sustain anywhere near its present population if everyone lived as profligately, each using as much energy and eating as much beef as the better-off Americans do today. On the other hand, 20 billion could live sustainably with a tolerable, albeit ascetic, quality of life if all adopted a vegan diet, travelled little, lived in small, high-density apartments, and interacted via super-internet and virtual reality. This latter scenario is plainly improbable, and certainly not alluring, but the spread between these extremes highlights how naive it is to quote an unqualified headline figure for the world's carrying capacity. A world with 9 billion people, a number that could be reached or indeed somewhat exceeded by 2050, needn't signal catastrophe. Modern agriculture, low-till, water-conserving, and perhaps involving genetically modified GM crops, together with better engineering to reduce waste, improve irrigation, and so forth, could plausibly feed that number. The buzz phrase is sustainable intensification. But there will be constraints on energy, and in some regions, severe pressure on water supplies. The quoted figures are remarkable. To grow 1 kilogram of wheat takes 1,500 litres of water and several megajoules of energy. But a kilogram of beef takes 10 times as much water and 20 times as much energy. Food production uses 30% of the world's energy production and 70% of water withdrawals. Agricultural techniques using GM organisms can be beneficial. To take one specific instance, the World Health Organization, WHO, estimates that 40% of children under the age of 5 in the developing world suffer from vitamin A deficiency. This is the leading cause of childhood blindness globally, affecting hundreds of thousands of children each year. So-called golden rice, first developed in the 1990s and subsequently improved, delivers beta-carotene, the precursor of vitamin A, and alleviates vitamin A deficiency. Regrettably, campaigning organizations, Greenpeace in particular, have impeded the cultivation of golden rice. Of course, there is concern about tampering with nature, but in this instance, new techniques could have enhanced sustainable intensification. Moreover, there are hopes that a more drastic modification of the rice genome, the so-called C4 pathway, could enhance the efficiency of photosynthesis, thus allowing faster and more intensive growth of the world's #1 staple crop. Two potential dietary innovations do not confront a high technical barrier: converting insects, highly nutritious and protein-rich, into palatable food, and making artificial meat from vegetable protein. As for the latter, beef burgers, made mainly of wheat, coconut, and potato, have been sold since 2015 by a California company called Impossible Foods. It will be a while, though, before these burgers will satisfy carnivorous gourmands for whom beetroot juice is a poor substitute for blood. But biochemists are on the case, exploring more sophisticated techniques. In principle, it's possible to grow meat by taking a few cells from an animal and then stimulating growth with appropriate nutrients. Another method, called acellular agriculture, uses genetically modified bacteria, yeast, fungi, or algae to produce the proteins and fats that are found in, for instance, milk and eggs. There is a clear financial incentive as well as an ecological imperative to develop acceptable meat substitutes, so one can be optimistic of rapid progress. We hope you've enjoyed this Princeton University Press audiobook of On the Future by Martin Rees, read by Samuel West, with the preface and introduction read by Martin Rees. For more information about this and all of our unabridged audiobooks, please visit press.princeton.edu.